Hey guys, alright, from the last problem we worked, we took x plus 2 and we divided it into this polynomial, came up with this quotient, and we had a remainder of 0. And therefore we were able to say that this is a factor. Alright, so what I wanted to be able to do is show you that in looking at x plus 2, meaning that what that says is x equals a negative 2, look right there, this is the actual polynomial graphed on Desmos, and that is a 0 of it. So what happens though if we have a factor or we have a divisor that is not a factor? And that's what I want to be able to look at in this video. And we deal with that with our arithmetic long division also. We end up with the remainder. So here's my problem. I have a divisor of 8, a dividend of 22, and my quotient for this problem is a 2 with the remainder of 6. 8 times 2 is 16. I subtract that from 22. I end up with a remainder of 6. And with your arithmetic, you were supposed to write the answer as 2 and 6h, which simplifies to 2 and 3/4. Notice I said and. Mixed number fraction is the same as a decimal. This, if I were to just type it in my calculator, I would end up with 2 and 75 hundredths. Therefore, I can say 2 and 3/4. A little outside of the context, but what it leads to is that that decimal point, and just that space that separates the whole number from the fraction can be viewed as having a plus sign in between them. I am saying 2 plus 0.25 and 2 plus 3/4. Where this comes into play is being able to understand your answers, what they're telling you. But for what we're looking at is we're looking at this concept right here. I have the divisor times the quotient plus the remainder will equal the dividend. Which you look at and you say, okay, that does make sense. 8 times 2 plus 6 equals 22. Well, I can take this concept and apply it to polynomial long division and end up with the same answer or the same context as up here with basic arithmetic. So let's say I'm going to choose to divide the same polynomial we did last problem by x plus 1. Again, my lead term in each one is what indicates what I'm going to have up here as my quotient. How do I turn x into x to the fourth? Well, I multiply by x to the third. X to the third gives me x to the fourth, and then I also have to do it to the 1. So x to the third times 1. I am subtracting, so it's the same as multiplying through by a -1 or flipping the signs. And then you add them together. As I work through here, each time dropping down my value, I end up with the remainder of 4. This is how I properly write that remainder. Just like I did here, I took the remainder and placed it over the divisor. Here I take the remainder and place it over the divisor. But for what we're looking at in basic understanding of what we're doing, I still get the same answer. If you want, even though it's not worked out, pause the video, multiply the divisor and the quotient, and add the remainder, and you will end up with the dividend, what was underneath the long division symbol. Not all of our divisors are going to go into our dividends evenly. We will have some that are remainders, and that's an important concept that we'll build upon. There's nothing wrong with having a remainder. A remainder of 0 indicates that it is a factor, but it's also an x-intercept, a 0 of that given polynomial. All right, so let's work an example. the question asks, is x minus 3 a factor of x to the third minus 2x squared minus 11x plus 12? Which, as soon as I read this, I should know if it is, then I will have a remainder that equals 0. Then yes. A remainder of some other value? Then no. So let's see. I say x minus 3 will go into x cubed minus 2x squared. Okay, so first thing I look at is, okay, what times x can give me x cubed? X squared. X squared times x is x cubed. X squared times a negative 3 is a negative 3x squared. Multiply through by a negative 1, that flips the signs. Now I add them together. Whole point is to make this become 0, and it did it. So I'm left with x squared, and I drop down my 11x. This right here is what I'm going to base everything off of. How many times, or what times x will give me x squared? X. X times x is x squared. X times a negative 3, that's a negative 3x. Again, flip the signs. That gives me a 0, which is what I wanted, and that's a negative 8x. Drop my 12. What times x can give me a negative 8x? So minus 8. Minus 8x plus 24. Flip the signs. Add them together. Gives me a 0. That gives me a negative 12. I have a remainder of a negative 12. No. X minus 3, or also show it like this, x equals 3 is not a factor, because there was a remainder other than 0. We'll do one more. How about x minus 4? Let's see if x minus 4 is. And there is not a rhyme or reason to it. It's a matter of just being able to plug this in and look at it through division. Again, we could factor this and find out. We could just take this polynomial and factor, but some polynomials are very hard to factor, and this is a way in which we can go around it. So, what times x will give me x cubed? X squared. Gives me x cubed minus 4x squared. So minus and plus. 2x squared, drop my 11. What times x will give me 2x squared plus 2x. So that gives me 2x squared minus 8x. Negative 3x, drop my 12 down. So minus 3 minus 3x plus 12. That becomes plus, that becomes minus. I end up with 0. So yes, x minus 4 or x equals 4 is a factor of the dividend. It's a factor, and I'll write it like that, of dividend. It's not a factor of the dividend. Okay, that's what we're looking at. And let's take a look at the graph of that polynomial, the dividend polynomial. And if I look at my graph right there, what we just solved for was, we said x minus 4 would go in there, went in there, and it had a remainder of 0. So x minus 4 is a factor, or I could say x equals 4. And then the other one that we looked at that wasn't was x minus 3 or x equals 3. And see, there isn't one there for x equals 3. It has a different value of a negative 12. So how about we look here? Whenever x is 3, so I'm going to get it right on there. Yes, when I get it on there, and look at that, 3 comma negative 12. That was my remainder in the first one. Excellent. I'll go ahead and show you this because we will build upon it. So whenever f of 3, we plugged in a 3, negative 12. For this one, f of 4 equals 0. Remember, this is how I can just turn around and write my x and y. That's just 3, negative 12, and this is 4, comma 0. Okay guys, that is our polynomial or algebraic long division, and this part of the video dealt with how to look at remainders and determine if your divisor is a factor of the dividend. Please watch your instructor's videos, the publisher's videos. Please structure and critically think about your homework, and good luck with completing the homework that deals with long division.